I'm going to do Leetcode 283 move zeros. In this question, we're given an integer array, and for example, this one right here. And there's might be some zeros in the array like this and that other one. So what we got to do is move all the way to the end so that we got the zeros on the right-hand side of the array. But the catch is you have to leave the order of the elements unchanged. That is, if you have like 1, 2, sorry, 1, 3, 12, and you still got to keep that order. You cannot have like 3, 1, 12. Okay, so the approach here is very similar to the other question, remove element, in that you're gonna go through the array, traverse it, and you're gonna keep a pointer. Okay, and then what we're gonna do is basically, if I don't see 0, you're gonna take copy the current element that I'm seeing to the position that I'm keeping track of. Usually the pointer starts at the beginning. Let's call it K. And then, for example, this one, if I have the I would traverse here. And as long as it's not 0, I'm going to copy. And this one is not going to go, but this one is going to go because it's 0, not 0. And I'm going to take that 1 and copy to the position where the K is. So the one will be copied there. So as you can see, it's very similar approaches in remove elements. So because every time that I see a 0, I kind of skipped and leave some room there that eventually will be taken up by the next non-zero element. So by the time you finish that, you're going to be left with like 1, 3, 12, but then you're going to have the 3 and the 12 remaining at the end. And that the trick here is the first pass that you go through is just to move all the elements to the beginning to its place. But since you're given that these zeros have to be all the right-hand side, you're going to do a second pass, a second loop that would just start from here and fill all of these with simply 0. So you're going to put 0 here, you're going to put 0 here. That way you can achieve time complexity O of n for this problem. Okay, so let's do it. So I'm going to use Java here. So let's make a loop here for int I. So the index variable I initializes 0 as long as I is less than nums.length, and then I plus plus. I'm going to look at nums at I, but then I got to keep track of that pointer. That's always going to be the next position for the element non-zero that I see. So I'm going to call that K, initialize to 0. And basically, I'm going to see if that current num is not 0. If that is the case, I'm going to go at the position 0, sorry, at the position K, which initially is 0, and I'm going to replace that with the I, okay? And because I do this, the position at K has been taken, therefore I need to increment the pointer to the next available one, which will be simply K plus 1, which is K plus plus. And once I do that pass, every element that's not a 0 would have been shifted and pushed to the left-hand side, while leaving room for all the remaining elements that are supposed to be 0. So that's why outside of this loop, following it, we need to make another one. But in that case, you can just start from the value of K, because if you recall, when you increment K, it goes to the next possible position for the next non-zero. By the time you finish the first loop, the K will be right at the perfect position. So you just got to fill that out. So you can just do either for or while. So for example, while the K is less than the nums of length, you're basically going to take a position at the K and set it to 0 and basically K plus plus there. That way you fill the right-hand side remaining with zeros. And it's a void function, so it doesn't return anything. So it's changing the things in place. So let's run. Okay, so it's been accepted. You can see this one. The 1, 2, 3, 1, 3, 12 move to the left, and everything else is 0. Time complexity of this should be, like I said, you have one loop and another one, but in the end, it's going to be all one. We don't have nested loops. So, and for the space, we're not using any extra space. We're changing everything in place. So O of 1 constant. Hey, thank you for watching. If you like this content, please consider making a donation so I can keep doing this for you. I'd really appreciate that if you could donate. All right. Thank you so much, and I'll see you in the next one.